feel like it's easier if we set it up a different way. Okay, that's where okay. So there's three categories. Okay, so the middle one, the suffix, and the prefix. Okay, the middle one I call the root. This is also called, in my Jake's way of naming, everything else. We're going to start with the root, and you can start with the root or you can start with the suffix. And then if nothing in your molecule fits in any of those, everything else goes in the prefix. Okay, so what does that mean? So let's start with this. So the root, this is what is always going to contain the longest carbon chain that's connected to your highest priority functional group. Okay, we'll leave that as a little mystery for now. Okay. What else does it include? Well, is it in a ring? And is there a double bond? And where is that double bond? Okay, and you'll see that if I help you with a problem, once we start doing a practice problem, this is exactly how I walk through it. I say, what is my longest carbon chain connected to my highest priority functional group? Is it, and you're gonna you really don't even need to ask yourself, is it in a ring? You're gonna immediately, notice if it's in a ring or not. And then I'm gonna say, is there a double bond in this longest chain? Yes or no? Yes. Well, where is it? Well, it's on the starts on the 3 carbon. Okay, that's what's in your root. Okay, that's like the core piece. And then the highest priority functional group goes at the end, and everything else goes in the beginning. So what's my suffix? It's my highest priority functional group. So if you look at your sheet, right, it's very methodical how it's organized. Starts at carboxylic acid, it goes all the way down to an alkane, right? Whichever is highest that is in your molecule is going to be your highest priority functional group, and you use your suffix notation for that. So look, can I do that again? So if you've determined that your carboxylic acid is your highest priority functional group, then the end of the name of this molecule is going to end in oic acid or oic acid. If you've determined that aldehyde is your highest priority functional group and there's nothing else above it, that means your molecule's name is going to end in al, Al. Okay, does that make sense? Okay, then you no longer ever need to use that suffix category. That's only for the highest priority functional group. Everything else is going to be the prefix term for it. Okay. And then a little stipulation here. Where is it? A lot of the times they're chain terminating, meaning that it's at the end. So if we have like a carboxylic acid, it's impossible for it not to be on carbon 1. Right? There's no way for a carboxylic acid not to be on carbon 1, because if it was not on carbon 1, then you couldn't have a carboxylic acid structure. And if that doesn't make sense, trust me, and it'll, as you work with molecules a little bit longer, you'll start seeing that, okay? But for example, if your highest priority functional group is a ketone, that ketone has the potential of existing on many different carbons, right? So you need to be specific and say, oh, this ketone is on the 3 carbon. And you might have asked, well, why didn't we name it from the other direction? Well, it's like in division, how you're not going to leave a fraction at like 6/12, right? You're going to reduce it to the lowest number possible. So in naming, you want to order it in the way that gives everything the lowest number possible, right? 1, 2, 3, 4, this could technically be 4 owned, but the other person would say, well, it's 3 owned because why would you give it 4 when it could be 3? Does that make sense? Okay, if this is still a little confusing, that's when we start doing practice problems, it'll kind of solidify. I'm just illustrating the fact that sometimes you don't have to include the where, and sometimes you do have to tell me where that highest priority functional group is. Okay? We're making a good headway here. Any questions so far? Yeah, so we do have questions. 1, 2, 3.
Okay, why didn't you count from the left? Like, why does it have to be 3 own? Like, I kind of don't get that.
So first, before I answer that question, let me give you an explanation. A lot of the why questions, like why is it this way? The conventional chemistry naming is IUPAC. And IUPAC is like a set of rules that tell all of us how to name molecules. So to answer your question, why did we start from the right and not from the left? Well, we started from the right because if we count from the right, it gives it the highest priority function group a 3. But if you started from the left, it would give it a 4. You might ask again, well, why is that? You just want to have the lowest number possible.
So is it usually gonna be ketones and esters like one?
Esters are also chain terminating. Because this is a special piece that isn't part of that longest carbon chain. So the longest carbon chain terminated there at that carbonyl carbon. But so generally we have the ones that can be anywhere would be ketones, alcohols, thiols, amines. Those ones can exist anywhere. Okay. All right, did that answer the question? And then we had a question up here and then.
That was my question.
Oh, that was your question? Okay.
So if there's just like a ton of carbon chains coming off of that oxygen on the ester, for example, like way more than on the other side, you would still count the left side.
Yep, so like we go back to our root here, it has to be the longest carbon chain that's connected to your highest priority functional group. And we can even be more specific with carbonyl carbon. You might say, oh, well, this chain is connected to it by there, but it has to be that carbonyl carbon. That is the start of our longest carbon chain. Okay. Cool. Any questions? Yeah.
So would you put the 1 like right under the carbonyl or would you put it on the end?
Yes. So the carbonyl is part of that chain. It's 1.
Sweet.
Yes.
So say you have like a ketone in the middle of the carbon chain following the oxygen on the ester, like after the oxygen on the special part.
Oh,
So if you have a ketone going off there, how would you count?
great question. So let's say you had something coming off of here, like a ketone.
Yeah.
Is that what you're asking? Or if you had like an alcohol coming off of here, like an
Yeah,
amine?
I'm just wondering how you would count that because you've counted from your higher
Yeah,
functional group.
good question. And my answer is you're never, in this class, it doesn't exist. Okay. The only thing that's ever going to come off of your ester is going to be a plain carbon chain. Molecules that have other things exist, but for this class, it simplifies it to a point where that's all we need. Okay. So don't worry about that. You can watch, if you're curious, there's probably a billion YouTube videos that show how to name esters. Okay. Any questions? Questions are good. We're not going slow. This is about the pace. We need to be going.
So did you say that esters are chain terminating? And if they are, then how does it have a lot of?
So when I say chain terminating, it's the longest carbon chain that's terminated. So what's our longest carbon chain? 1, 2, 3, it's 4. And is it possible for this chain to continue? No, well, there's an oxygen there. Okay. Yes.
I'm sorry. You just counted it from the left to the right. What do you
Yeah.
count it from the other?
Sorry, I was just counting it numerically how big it is. You would always, if you're assigning it a number of like its location, you always got to start at the carbonyl. So 1, 2, 3, 4.
Okay, I was just making sure I didn't miss it if it was
Nope.
that way.
Great. Thanks for clarifying that. Yeah.
How do we know which chain is like the longest for the functional groups that don't have a carbon?
I'll answer that when we do a little more practice, because you're only gonna, to answer it quickly. You just find the longest carbon chain in it. Because this functional group is going to be attached to it. So you find whatever the longest carbon chain is, and then tell me where that highest priority functional group is coming off of. We'll do it, we'll practice name that one in a second. Yep.
And then with your highest priority functional groups, when you have, for example, like a carboxylic acid and ketone, for example, together, then it's always going to be the carboxylic acid.
Correct. You're not, in this class, you're not gonna see those two in the same molecule. He didn't give you the suffix for the prefix for ketones and the aldehydes and stuff. But yes, the carboxylic acid would win.
For the long one that you drew, are you just not gonna count anything on the side? As you just start counting on the highest?
Are you talking about over here?
Yeah.
We'll do a practice on an ester. This is what we would call a substituent. And it would be a special piece that goes at the beginning. So how long is this? It's 8 carbons. This would be a special octal. And that goes, and we'll do a practice. So pause on that. Okay, let's finish our little chart here. And this is where it gets a little bit of an ambiguous. Everything else goes in your prefix, okay? So substituents, I think that's how you spell it. Substituents is just a fancy term for things coming off of your carbon chain. So for example, we have this molecule here. Let's say we have an alcohol coming off of here and an NH2 group, an amine group coming off there. Those are both substituents. Okay. So you need to tell me what they are. So whether it's an alcohol, so that'd be, if you look at your sheet, that's hydroxy. Or if it's an amine group, it would be an amino. If it's just a carbon chain coming off of it, like that, it would be an eel group and how long the carbon chain is. Right, so you have to tell me what it is. You have to tell me where it is. And how many you have of them. And that would include di, tri. You're not gonna get more than that, but yeah, it would continue. You had like multiple, okay? And you organize these. Alphabetically. I don't know if it's double L, but my spelling's poor. So you organize these in your prefix alphabetically. Okay, not the di, tri. You just use the sub. You organize it alphabetically by the prefix name on your sheet. Okay, if this feels like a lot, we'll jump into some practice.
So like, for example, looking at that amine, so what if there's like 2 amines on that 1, 2, 3, on the 4th carbon?
On this one here?
No, the top left one, sorry. Yeah, so like what, if there's 2, would you say like diamine?
Yeah, so it's really repetitive. So you'd have to say, where is it? It's on the 4. Where's the other one?
Also on the
Also on the 4. How many do you have of them?
di.
2 of them. And what are they?
Amino. Wow, you know that?
Yeah, so it's very repetitive, but what makes it like not annoying repetitive is like
Yeah.
you don't simplify anything. It's just like it's as it is. Right. Okay.
And that would be first in the alphabetical order because it starts with an A.
A, not the die. Yep.
How do you know like when you use a dash and when to like just put it all together?
Oh, good question. So everything is always going to be together. And then if you have a number and a number, you do a comma. So if it's like 4 next to a 4, you do a comma. If it's a number to a letter, it's a dash. That makes sense? The only time that it's separate off of its own, so it's always one word except for esters. Esters are gonna be 2 words, because then you throw this guy, whatever it is, at the beginning as its own word. That's what we call. I call it a special ester. Yeah. There she is. So it's a special ester, okay? Let's do a practice one and then answer more questions. Maybe it looks a little complicated, but I just wanted a lot of pieces in there so we can practice a lot of these skills in one problem, okay? So the first thing I always do, you can either do either or. One, you can identify your highest priority functional group, or you can do the longest carbon chain. I say we identify my highest priority functional group and where it is. So what's my highest priority functional group?
Ester.
It's an ester. And actually, the way I do it is, I write in what that name piece would be. So what is it?
Wait.
So it's an ester, so that's an 08. Where is it?
And
Yeah, it's on the end, it's on the 1 carbon. So I can, if it's on the 1 carbon, you can, that's the only simplification that we have. That's the only thing you can drop ever in IUPAC naming. So I like to just keep it, it makes it very organized, so. Okay, and then what's my longest carbon chain? That's connected to that 1 carbon. 1, 2, 3, 4. Is it 5? What did I do? Oh, yeah. Is that 6 or is that one 6?
Matter.
Doesn't matter. Because if you label that one 6, then that's your substituent. If you label this one 6, then that one's your substituent, right? Let's say hypothetically, it looked like you had a big substituent going on like that. Then it would change the longest carbon chain to that, right? Okay, but don't change your problem. So I'll just label it like linearly, and then we have our substituents coming off up and down, okay? So we've labeled, and this hex 6s. Do I have any double bonds?
No.
Hey, that is my root with the suffix hexanoate. So we've finished our root here. Is it in a ring? Nope. We have the longest carbon chain. It's connected to our highest priority functional group, carbonyl carbon, and we identified if there's any double bonds or not. Yeah.
Why wouldn't you add the di or whatever, the dioate or whatever?
There's only one of them.
Oh, okay.
Yeah. Okay, so then we have to label our prefixes, or other way to say it, everything else. So what do we have here? 2 hydroxy. What do we have here? 3 hydroxy. That triggers in my head that I have a multiple of 1. So we'll combine them in the name. Then we have what here?
4 amino.
4 amino. And then what do we have here? So what's the prefix for 1? Meth. And if it's just a carbon chain, what's the little, take this. What's the suffix for, or the prefix for just an alkane? YL. Okay. Yes.
Explain the one.
Why this one? So what this, we haven't named this yet, right? It doesn't have a name yet because we named the longest carbon chain and the highest priority functional group. This is something coming off of it, which is a substituent. It needs a name. So it's not one of our functional groups. It's just simply a carbon chain. We have to say how long the carbon chain is and that it's a carbon chain. Okay, the YL is that it's a carbon chain. The meth tells you how many carbons it is. If it was 2 carbons long, it'd be eth. Or so it'd be methyl. And then if it was 2 carbons in length, it'd be ethyl. If it was 3, it'd be propyl, butyl, pentyl, etc. Does that make sense? So this is a methyl group. Okay, and then we alphabetize it and put it together. Okay, so we have our root is hexanoate. And we have 4 amino. And then we have hydroxy, right, would be next alphabetically. We have 2 of them. So it's going to be, tell me where they are. Both of them are, one's at 2, one's at 3, and that you have a multiple of them. So dihydroxy. And then lastly, if my spacing worked out perfectly. 4 amino, 2,3 dihydroxy, 5 methyl hexanoate. Pause. Did we name everything in this molecule? What are we missing? Yeah, so what is this? So this has, we haven't, it's not connected to my longest carbon chain. That means it's going to be its own word at the front of it, so it gets a space. So what is it? Well, it's a carbon chain. So we know my carbon chain is YL, right? And how long is it? 2 carbons, which is F. Will you have to name one that long? Probably not. Is it easy? Yeah, kind of. I mean, it's not very complicated. Just have to remember all your pieces. Okay, let's do another one. Okay. Any questions on that one? Yeah,
Is di or
good question. Di simply means a multiple of a functional group. So do we have multiple ethyls? No. How many carbons is this functional group? It's 2 carbons in length. And you label it YL. We have 2 functional groups. Imagine these were ethyls. Well, these were both 2 carbons in length. Then it would be 2,3 diethyl.
How does here the highest priority functional?
You're not, it exists, but we won't name those in this class. You would simply just put where they are. So let's say one was on the 1 carbon and one was on the 2 carbon. It'd be 1,2 dioic acid. But you wouldn't, that would never exist because you can't. Yeah. Yes.
Well, we have to go backwards, like will we be given a name and we have to draw the molecule?
Yes, but if you get really good at this, so I'd spend like 75% of your time on naming a molecule. Once you get really good at that, it is like, it's pretty much like a roadmap backwards. Like it's like reading Lego instructions. It's like, it's really simple in my opinion, if you get good at naming forward. Yeah.
How do you know if you're using an or?
AN or EN, if there's a double bond in your longest carbon chain. And we'll do one right now, okay? I'm gonna erase this one. Yeah?
would you need to put the 1 in front of the 08?
Nope, so if it's a 1, you can drop it. the highest priority functional group.
Yeah, how do you tell the difference between, say there was like a 3 carbon chain and not 5 methyl strong? How do you tell the difference between a substituent and then like just a continuous?
Good question. If that substituent, if it appears as a substituent, but it actually changes the length of the carbon chain, the other direction becomes a substituent.
So the ethyl in that case would just be, like, it wouldn't be connected to the carbonyl.
Yeah, for example, if this was an ethyl,
Yeah.
it wouldn't be an ethyl, because the longest carbon chain would go 5, 6, 7, and then this would be your methyl group. So it changed the root rather than your substituent. Yeah. Okay, let's do another practice here with a couple other things that we didn't do. And then we'll do a couple ring ones.
Count as a ring?
What?
Does that count as a ring?
No, it has to be, a ring is gonna be closed. Yeah. Okay, so if you wanna work on this yourself for a little bit, plug your ears and kind of plow through it by yourself. I'm gonna walk through it like I'm gonna do it as a student, okay? So I'm gonna follow the exact same rules that I did on, an easier one, or when we walked through some of, this chart here. So the first thing I'm gonna do is identify my highest priority functional group. My highest priority functional group is going to be my carboxylic acid, which is at the 1 carbon. And I guess this is the only other occasion that you'd have a separate word is space acid, but you kind of all understand them. And then the next thing I'm gonna do is so I did this. I want to then go to my root and find all these information. What's my longest carbon chain that's connected to number 1 here? Okay, well, I have like a crossroads here. Which direction do I go? Well, if I go this way, it's 5, 6. But if I go this way, 5, 6, 7. What's my longest carbon chain? Okay, so that means, and what's 7? Okay, so I've identified my longest carbon chain. What's next? I need to identify if it's in a closed ring. Esther pointed out that, is it a ring? No, it's not closed, okay? And the last I need to do for my root is identify if there's any double bonds in the longest carbon chain. Is there? And where is it? Yeah, so you always label the lowest carbon number. So if this double bond is between carbon 3 and carbon 4, we're gonna say in the name that it's at the 3rd carbon. Hopefully that answers your question there. So once you have an ene in there, you also introduce a number, because that ene could exist there, or there. So you have to be specific and tell me where it is. Yeah.
So if there was no double bond, would you use AN?
Yep, and no number. Yep. Okay, so I've named, my circle's gonna get a little weird here. I've named that. That all is part of a name so far. You can't tell me anything that's within this circle that can't be found in this, what I've drawn, right? Okay, so then we have to name everything that's not circled. Okay, so what's this coming off of carbon 4? Yeah, so how many carbons is coming off of? 2, which is F. And how do you tell me that it's a carbon chain? YL, where is it? 4 carbon, so we have a 4 ethyl. And there's just 1 ethyl, so it's not like diethyl, it's just we have one singular 2 carbon piece. Okay, what do we have coming off of carbon 5 here? We have two what?
Methyl.
Two methyls, right? It's one carbon. What's one? Meth. How do you tell me it's a carbon chain? Oh, so, yeah, so we'll condense it as we write it in here, right? Because there's two of them, right? Where's the first one? Where's the second one? Also at the 5. How many do we have? And what is it? And then how do I alphabetize this? By the methyl there, okay? Now, does everything in that whole entire molecule fit in something that we've named? Yeah, so now we just put it together. So, so it will be 4-ethyl 5,5 dimethyl, and I apologize for kind of the sloppiness there, but. So 4-ethyl hyphen 5,5 hyphen dimethyl hept 3-enoic acid. Mouthful, yes. Do you have to ever say it? And like someone has to like know what you're saying? No, you kind of read it as instructions on it to know what that molecule is. Yeah.
Right, I'm kind of thinking like if I had to draw that from that name, how would I know that the 7 carbon chain would look like that?
Good question. So like when you draw something, it might look different than what your neighbor draws.
Okay.
So what you're gonna learn is that these sigma, we call them sigma bonds or single bonds, are flexible. They rotate.
Right.
So did I draw it like this on purpose? Yeah, I drew it to for you to maybe think that the longest carbon chain was this, and that's the substituent.
Okay.
I drew it like this so that you had to, actively choose the south one as your longest carbon chain. So if you were to like draw it from the name, would your molecule, would these two be flipped? Potentially. Is it wrong? No. Yeah.
How do I know if that methyl goes first or the 4-ethyl?
Good question. It's by alphabetical order. E is alphabetically before M. That makes sense? You don't alphabetize these like duplicate prefixes. Yeah,
In the next example, could you add a ring?
yeah, the next one, let's do a ring. Okay, we ready for it?
Mhm.
Cool, I feel like you guys will walk out of here feeling like $1 million because naming's not really that hard if you kind of step it down like this. Let's make that bigger. Okay, here's our molecule. And I want to prove to you that none of your steps change, that it's in a ring. Only thing that you have to do is you have to remember to add in your cyclo there, and that cyclo goes at the beginning of your root. Okay, so let's do the exact same steps. You have to identify your highest priority functional group. In this molecule, what's my highest priority functional group? Ketone. And where is it? This is where you have a little bit of a liberty, and your liberty you could be wrong. There's only one right answer. You do have like a little bit of freedom to like choose, but you could be wrong. If that makes any sense. All I'm saying is that when you had a carboxylic acid, you were forced for that carbon to be 1. You couldn't err from that. But here you have a potential of saying like, hey, this is my carbon 1 and it's on carbon 2. Could you say that? Yeah. Is it right? No, it's wrong. Okay. So when it's in a ring and you have like a ketone, you want to give your highest priority functional group the 1 carbon. So where is it? Yeah, it's on the 1 carbon. And then your next decision with your agency is to decide, is my numbering going to go this way? So 2, 3, 4, 5, 6, or is it going to go this direction? Yeah, and it's the same reasoning why when I was drawing those two examples there of going numbering from right to left, why we chose the one that went from the right. Because it gives the largest set of substituents the lowest number possible. If we went this direction, the double bond here would be at 4. The alcohol would be at 5, and then both these methyl groups would be at 6. Well, where if we went this way, the numbering is minimized. Does that make sense? Yeah,
Can you get 7 carbons though if you went the other way, and aren't you looking for the longest carbon chain?
good question. Does anyone want to agree or disagree with her? Agree? Okay, we have some agrees. When I took this class, I agreed too. I was like, "Ah, heck yeah, like I'm gonna go this way, make a 7 carbon chain. I'm right. No one else is gonna get this, okay? An IUPAC rule, and that's why I'm saying this isn't chemistry. This is just following like grammar rules of chemistry. A rule is once you are inside of a chain in numbering, you can't exit the chain. So let's say hypothetically this. What's my highest priority functional group? A ketone, and what's my longest carbon chain? 6. And this is not chemistry, this is just simply following the rules of IUPAC naming. So if I'm numbering here, I can't exit the chain with a number. Those are all gonna be substituents. Okay? Cool. So we're gonna label the root here, and the root is 6, which is hex. And is there any double bonds in the longest carbon chain? Yeah, where is it located? 3-ene, and my highest priority functional group is located 1 carbon. It's at the 1 carbon, so we can drop the 1. And what's the last thing I'm missing in my root? Cyclo. Yeah.
If you ever had like a carbon chain coming out that was longer than the ring, like, would you ever label that instead of always interesting?
Nope, because your highest priority functional group, your longest carbon chain has to be connected to that carbonyl carbon.
Like going off the side.
Like here,
Yeah.
if that was longer, it'd still be the chain because the ketone is in the ring. That 1 is still part of the ring. But that's getting like way beyond where we're gonna name in this class, okay? So we've named our highest priority functional group. We've named the backbone of the molecule, and now we just have to label everything else in the prefix or as a substituents. So what do I have here? I have 2 methyl groups, right? They're 1 carbon in each, so it's meth. What are they? They're carbon chains, so it's eel. How many do I have of them?
2.
And where are they?
2.
And then anything else?
Like drugs.
And where is it? Okay, so we alphabetize by, so my name is going to be 3-hydroxy 2, 2 di methyl cyclohex 3-ene. Oh. Sorry if it's a little small. 3-hydroxy -2, 2 dimethyl cyclohex 3-ene own. I guarantee, and then maybe a couple more reviews. Other TAs, there's going to be like a question or a debate about, maybe you're arguing about what side should I actually number, because this side might have an amine, this side might have an alcohol. It's not going to get that trivial in this class. We always answer as TAs every semester. I feel like I'm going to leave it as is. That you never see it. You're never gonna have to like decipher between an alcohol and an amine and decide which one, right? The answer is you go by priority. But which one's higher, alcohol or an amine? Alcohol, so you just go to the number where the alcohol is the lowest. Yeah,
So isn't there a website to practice these?
maybe.
You had a website that you recommended.
Not me, no. I wish I did that. Let me ask the other TAs. I'll send a text out. I'll see who has that. Yep.
Dash between dimethyl and this flow, or you just do that?
Nope. So the only time dashes go there is as if there is between a number and a letter. So dimethyl cyclohex 3, no. You might see like, I think sources online give you that. Yep, you won't see it though in this class.
Can you do an example with 2 alkenes?
2 alkenes, yep.
Or CHEM 101 in writing lab
OChem,
and 101.
OChem 101 Learning Lab. Okay, maybe search that up on Google and see if that gives you a good result. I'll still text the group and see if there's a different one. Okay, 2 double bonds. Which you will probably see, which is, I'm glad she asked. What was your name? Thanks for asking, Sydney. Let's do it. You want to do a ring or a chain?
Oh, wow.
Okay, let's jump through this one quickly. So remember, the first thing I'm always gonna do, identify my highest priority functional group and tell the reader where it is. And the next thing I want to do is my longest carbon chain that's connected to the carbonyl carbon. Five. So that is pent, right? Are there any double bonds? Awesome. So you're gonna do this actually the same way that you would a substituent. So you tell me where they are. So you have one here at the 2 carbon. And then you have one at the 4 carbon. And how many do you have of them? So one's at the 2 carbon. One's at the 4 carbon. You have 2 of them. And then what else haven't I named yet? Looks kind of ugly, but that's how you do it. Dienone. Yeah.
So why wouldn't you add the cyclo? Cause since it is a.
Oh, yeah, I'm an idiot. I jumped one of my steps. I made an error. I would have lost points on that, right? I know. Right, so it's worth your while to like very methodically think through these, like, what's my highest priority functional group? Highest carbon chain or the longest carbon chain connected to that highest priority functional group. Are there any double bonds? And lastly, before I move away from my root, make sure you remember that. Well, of course, I noticed this in a ring. Did I remember to label it as such? Okay. First of all, that should allow you to do your homework, knowing that. And 2, I feel like that will, you guys know naming if you either rewatch this or do it again. Or like practice some of these on your own. Yeah,
Off the question, but it was in class today.
yes,
So it's being oxidized going up in oxidation
yes,
and reduces going down.
correct.